Okay, let's finish up with number 6 on trig unit test review worksheet number 3. So we want to sketch a graph of our function 1/2 x minus cosine x with all the related information. So first step, find the derivative. 1/2 x goes to 1/2, cosine x goes to negative sine of x. So two negatives cancel out to be a positive. Set that equal to 0 to find our critical point, and then set sine of x equal to negative 1/2. So sine is equal to negative 1/2 in the third and fourth quadrant, 7 pi over 6 and 11 pi over 6. However, we have to look at our interval here. Intervals between negative pi and pi, so we have to make some adjustments. So we have to write this as negative pi over 6 and negative 5 pi over 6. Okay, we put this, the two critical points on our sine line. Okay, and now we're going to be testing each interval with the derivative. Okay, between negative pi and negative 5 pi over 6, this is going to be in the third quadrant. However, there's not any special angle that we can use without a calculator to find what's between negative pi and negative 5 pi over 6. However, we do know what sine of negative pi is, which is 0. Okay, we do know what sine of negative 5 pi over 6 is, which is negative 1/2, negative 0.5. So sine of an angle between 0 and negative 0.5, we can choose, let's say, negative 0.3. Okay, so negative 0.3 plus 0.5 will give us a positive value, 0.2. So we know that this interval will be positive, increasing slope. In this region, I can choose negative pi over 2. So sine of negative pi over 2, same thing as sine of 3 pi over 2, which is negative 1. Negative 1 plus 1/2 is negative 0.5, so I know this interval will be negative. Okay. This interval here, I can, again, there's no special angle between negative pi over 6 and pi, but I know sine of negative pi over 6 is negative 0.5. Sine of pi is 0, so between negative 0.5 and 0, let's say negative 0.3 again. Negative 0.3 plus 0.5 is again positive 0.2, so increasing slope. Okay. Based off of this, I know there's a relative minimum at negative 5 pi over 6, so plug negative 5 pi over 6 back into the original function to get the y value. So negative 5 pi over 6 in for the x, so that will give me, if I multiply this out, this will give me negative 5 pi over 12 minus cosine of negative 5 pi over 6, which is negative root 3 over 2, so two negatives cancel out to be a positive. Now I just want to know a ballpark value for this so that I can graph, since we don't have a calculator. But pi, we can think of pi as 3, right? Negative 5 times 3 is negative 15, and 15 over 12, think of this as negative 5/4, which is about negative 1.25, plus treat root 3 like 1.5, 1.4, 1.5, right, roughly. 1.5 divided by 2, that's about 3/4, so plus 0.75. So negative 1.25 plus 0.75 gives us a value probably close to around negative 0.5. Okay, so just enough information to kind of know where we're going to be graphing. Okay, we know the relative minimum is going to be a negative pi over 6, so we plug negative pi over 6 back into the original equation. Multiply this out, we get negative pi over 12 minus root 3 over 2. So think of this as negative 1/4 minus 0.75, which gives us negative 1. Okay, roughly negative 1. Okay, moving on to the second derivative, we set, let's see, 1/2 goes to 0, sine goes to cosine. So we set cosine equals 0, cosine is 0 at pi over 2 and negative pi over 2. Again, we have to make sure our radian measurements fall between our interval. Okay, put this on the sine line, and we can see that if we plug negative pi over 2, let's see, we first need to test the interval. So between negative pi and negative pi over 2, this is going to be in the third quadrant. So any cosine value in the third quadrant will be negative. Between negative pi over 2 and pi over 2, right, between negative pi over 2 and pi over 2, that's in the fourth and the first quadrant. So cosine of any angle in the first or fourth quadrant will be a positive, so concave up. And then between pi over 2 and pi, that's in the second quadrant, so cosine of any angle in the second quadrant is going to be a negative, so concave down. So changing concavity at each of the critical points, so we know that both of these will be points of inflection. Okay. To find the ordered pair, we can plug negative pi over 2 back into the original equation. So that'll give me negative pi over 4 minus cosine of negative pi over 2. This will give me 0, so negative pi over 4. Plug pi over 2 into the original equation. I'll just get pi over 4 minus 0, which is pi over 4. Okay. Relative extrema, we know we found a relative minimum, and this is because f prime changes from negative to positive. Relative max, we found this, and this is because f prime changes from positive to negative. Points of inflection, we found because f double prime changes signs. Concave up in this interval because f double prime is positive. Concave down in these two intervals because f double prime is negative. Alright, we can go ahead and put our results from our first two sign lines onto one sign line so we can match up the slope with the concavity. And the next step is just to find the order pairs for the endpoints. So the order pair for the endpoints, plug negative pi into the original equation, and I'll get negative pi over 2 plus 1, which is about negative 0.5. And then plug pi into the original equation, so pi over 2 minus cosine of pi, so about 1.5 plus 1, which is about 2.5. Okay. From there we can, with all the decimal approximations that we found, we can plot those points, okay, over here on our graph, and we can sketch our graph based off of our concavity and our slope. Okay, so relative max here, relative min, followed by change in concavity, and then endpoint. So based off of this graph, we can tell that there's going to be an absolute minimum at negative pi over 6. So absolute minimum, this is the exact y value. And absolute maximum, the exact y value is pi over 2 plus 1 at this endpoint.